The ancient Greeks believed, after the ideas of Democritus, that you could divide matter into smaller and smaller pieces until you hit the smallest bit, which was called an atom, or atomus, which means indivisible in Greek.
This theory was widely accepted for thousands of years, until a Quaker schoolteacher called Dalton came along. He studied the chemistry of atoms and set forward new ideas, building on the Greek ideas of the atom. He said that all atoms of the same element were identical, and that molecules were made up of combinations of elements.
After Dalton, scientists began to debate whether the atom was atomous at all, or if it could be divided into smaller pieces.
Atoms are made of smaller bits.
The discovery of the electron by J.J. Thomson furthered this theory through his cathode ray experiments. Here he discovered that electron beams could be bent due to electric and magnetic fields.
From this, scientists developed the plum pudding model, which consisted of a ball of positive charge with electrons dotted around in it.
I must prove this.
Rutherford decided that to prove this, he would show how alpha particles travelled through gold foil, but his experiments had unexpected results.
Instead of the alpha particles uniformly travelling through, they were scattered. Some travelled straight through, some were slightly deflected, and some were completely rebounded. This showed that the atom was mostly empty space, with a dense nucleus at the centre.
Through further experiments of splitting a nitrogen atom and releasing a hydrogen nucleus, Rutherford discovered the proton. But his calculations showed that if only protons were present in the atoms would be roughly half the weight. Therefore, neutral neutrons must be present to make up this extra mass and hold the protons together.
This was then proven by James Chadwick.
And now for the complex part.
The quark model was considered in the 1960s to further divide the atom. Following experiments at the SLAC, based upon Rutherford's early experiments, but on a much smaller scale, a proton was bombarded by electrons, which bounced off in 3 different paths, showing that a proton consisted of 3 smaller particles, now named quarks.
Quarks come in 6 distinct flavours: up, down, top, bottom, charm and strange. But nucleons, the 2 particles found in the nucleus, consist of only 2 of these. The ingredients for a proton are 2 up quarks and 1 down quark. The recipe for a neutron is 2 down quarks and 1 up quark. Protons are the only stable hadrons when apart from the nucleus.
Electrons are a different matter entirely. Scientists still can't grasp these, and they have no known substructure. They don't even know if they're a particle or a wave, but quantum theory dictates that they can be both.